All right, today we're going to look at applications of systems of linear equations. So basically these are word problems where you're going to use the techniques from the past two classes, solving algebraically or solving graphically, once you've gleaned the information from the word problem. We're going to look at applications of systems of linear equations today. We've learned how to solve systems of linear equations using three methods. We can solve graphically, you can solve by substitution, or you can solve by elimination. So today you're going to be allowed to use whatever method you want to solve, but the point of today's lesson is to learn how to take a word problem and use a system of equations to solve it. All right, so in our first example, we have two types of candy. One type is $2.50 a pound, and the other type is $4 a pound. And a store clerk is trying to make a 5-pound mixture of the two kinds of candy. So let's just say if he was going to do all 5 pounds of the more expensive candy, how much would it cost?
You're going to do 5 pounds, so it would end up coming to $12.50. 5 times 200.
Oh, that's the less expensive candy.
Oh,
yeah.
$4.
Yeah.
$20.
So if we did all the cheap candy, right? Yep. 5 times 250 would be 5 times 250, 12.50. Yeah, you're right. $12.50. All right, what if we did all expensive candy? $20, right? $5 per pound times $4. 5 pounds times $4 per pound, $20. So does it kind of make sense that the person who owns this candy store, he could build some kind of mixture where he'd take some of the cheap candy and some of the expensive candy, and 5 pounds would cost $17.60. Right. He's going to be bound to the 1760. His goal is to make a mixture that he can sell a 5-pound bag of for $17.60. And it seems possible because 1760 is somewhere between all cheap and all expensive, right? So we can sort of pull some of each and make a mixture that would cost $17.60. So your first step is to define your variables, and to do that, you first identify the question, right? I like to just underline the question. How much of each type of candy? There's two types, so I let one variable be each type. C will be the cheaper candy, and E will be the number of pounds of the expensive candy. Number of pounds of cheap candy and the number of pounds of expensive candy. And then I like to organize all of the given information into a table. So to start out, I will give you some tables, and then after a while, you'll start making your own table. Okay. So cheaper candy. How many items do I have of cheaper candy? Yep, C is what I defined that to be. The number of pounds of cheaper candy, so that's going to be C. And for expensive candy, that's E. And then how many total pounds of candy will I have if I put them together? 5 pounds. That's what I'm looking for, right? I'm trying to make a 5-pound mixture. So I put a 5 there. All right, what is my cost per item for the cheaper candy? $2.50. And my cost per pound for the expensive candy? $4. Okay. Now, when I asked you how to figure out what if it was all expensive candy, you multiplied 5 pounds times $4 a pound to get the $20, right? So multiplication feels natural when you have a number of pounds and a cost per pound. But now I have a number of pounds is just a letter. So I have C pounds of candy that cost $2.50 per pound. So when I multiply those together, I get the total cost, which is just going to be $2.50 times C.
Okay, now he's trying to get a cost of $17.60. The
yep.
numbers you have up there, you're going to end up with $17.50. Like something close. You're not going to end up with $17.60. You're going to end up with under that.
All right, so let's put the 1760. What box should I put the 1760? The total value of my candy is my goal is I want that to be 1760, right? So let's see if we can make that happen. So you're saying I think it's going to come out close but not exact.
Yeah.
Let's see. Let's just see if what happens. So I have E pounds of expensive candy that costs $4 per pound. My total cost would be the number of pounds times the dollars per pound. So I would get 4E. Okay. So it actually doesn't matter what the cost per pound is of the mixture. So I'm just going to leave that one blank. It's not given in the question. So sometimes if something's not given, sometimes it doesn't matter. Sometimes you have to figure it out. Right? So in this case, try to write your equations, and then if you need something else, you can go back and try to figure it out. Okay, so can we come up with two equations from this table? Because I've got two unknowns, C and E, so I'm going to need two equations. Not you. Go ahead. Yep, C plus E has to equal 5, because C is the number of pounds of cheaper candy. E is the number of pounds of expensive candy. When I put them together, I'm supposed to get 5 pounds total. Okay, so I've got C plus E equals 5. And then another equation. Great, thank you. The total value, the amount of money that the cheaper candy is worth, plus the amount of money the expensive candy is worth, is supposed to add up to $17.60.
Would it come out to less than or equal to 1760? Or it's going to come out exactly 1760?
My goal is to come out to exactly 1760. I want to choose a value of C and a value of E. How many pounds of cheap and how many pounds of expensive candy will it take so that I can add them up to 5 pounds and that the total value will be $17.60. So I have two unknowns and two equations. Can I solve it? Yeah, I can use any of the three methods that we've talked about so far. I'm going to let you try to solve it yourself a little later. But the answers turn out to be 1.6 pounds of cheaper candy with 3.4 pounds of expensive candy. That adds up to 5 pounds of candy. And if you do 250 times 1.6 plus 4 times 3.4, you get exactly $17.60. Okay. The amount of money that you put in a savings account is called the principal, and the money a person earns from the bank is called interest or interest income. So just really quick, if I put $100 in the bank and it makes 8% interest, after 1 year, you would make $8. 1 year interest is $8. How'd you come up with that, Don?
What's 8% of 100?
8% of 100, and what mathematical operation do you do to calculate 8% of 100?
You multiply by 0.08.
Yeah, you could multiply 100 by 0.08. There are other ways to do it too, like some people might set up a proportion, but in general, you take 8% of $100, and there's several ways to do that. So all I did was I multiplied the principal, which is $100, times the interest rate, which was 0.08. Okay. Yes. All right, so moving on to another example. Jerry invested $2,000 in two different banks. One bank pays 4% interest, and the second bank pays 9% interest. So he has some money, has $2,000 total. Some of it's making 4% interest. Some of it's making 9% interest. His yearly income from the 9% investment is $37 more than his yearly income from the 4% investment. How much did he invest at each rate? So I underline that question, and I use it to define my variables. Okay. So I'm going to let L be the amount he invested at the lower rate and H be the amount he invested at the higher rate. And you can pick whatever letters you want, right? Sometimes I pick letters that help me remember what they represent. Sometimes I just pick X and Y because those are the standard variables, right? All right, let's try to organize our information into a table. How much money was invested at the low rate? We don't know. So what was the variable that I called that amount? L. And what do I put in for the high rate? H. Okay, and what was my total money invested? $2,000. $2,000. Okay, my interest rate at the low rate is 4%. How do I write 4% as a decimal? 0.04. You got to move it 2 to the left. 0.04. And my high rate interest rate is 9%, so I would write that as 0.09. That leading zero doesn't matter, right? You can write it or not write it, it does not matter. Can't leave it as one way and one the other way. Okay, I don't know what my total overall interest rate is. They didn't tell me in the question, so I'm going to leave it blank for now, and if I have to figure it out later, I'll try to figure it out. All right, my amount of interest income. So up here, when I gave the $100 at 8%, we just multiplied 100 times 0.08, right? So now instead of $100, I have an L. So I'm going to multiply L times 0.04, and I get 0.04 L. And my amount of money in the high interest rate, I multiply that times my interest rate of 0.09, and I get 0.09 H. And then what's my total amount of interest? 46? How do you know that? 9 plus 37. Oh, where'd you get the 9? Yeah, that's a percentage, not a dollar amount. Yeah. So they didn't tell us, right? They didn't tell us what his total interest is. They told us something about it, but not like the actual number, right? So I'm just going to leave it blank for now and see if I can write 2 equations. One of them I can read right out of this table. Anybody see it? L plus H has to be $2,000, right? The amount he invested in the low fund and the amount he invested in the high fund adds up to $2,000. All right, and then the amount he earned in interest, right? His income from the 9% investment. Let me do this in a separate color here. So his income from the 9% investment. What expression in this table represents his income from the 9% investment? 0.09 H. H was the amount he put in that investment, and his income, or his interest income, is 0.09 H. So that is 0.09 H that it's referring to. That's its expression. And they're saying 0.09 H is $37 more than his yearly income from the 4% investment. And what expression in the table represents that? 0.04 L. Yeah. So 0.09 H and 0.04 L are related to each other. Are they equal? No, one's bigger than the other. Which one's bigger? 0.09 H is bigger. So I'm going to write 0.09 H and equal sign and 0.04 L. They're currently not equal, right? 0.09 H is bigger. So in order to make these balance, where should I put a 37? On the right-hand side. Yeah, I need to add the 37 to the right-hand side to make those scales balance. So now you have 2 equations with 2 unknowns. I might rewrite this green one so it looks a little less messy. 0.09 H equals 0.04 L plus 37. And then you could pick your favorite method for how to solve these two. Anybody have a thought which one seems most efficient to you at this point? Yeah. Substitution. Why would you pick that one? So when you said they can cancel out, what are you referring to? Oh, so you're going to get one of the variables to disappear. Yeah. So if you were to use substitution, that is an efficient method in this case because it's easy to solve for the L or the H, right? You could do it in one step. Just subtract one thing and you have it solved. Should we do that? Do you need to review it or?
Yeah,
Let's review it. Okay. So if I was going to do this by substitution, you have to pick an equation and then pick a variable. So I'm going to pick this equation because it's the simpler of the two, right? Pick the simplest equation. Somebody pick a variable, L or H. I got both. Okay. L. Just picked it at random. Okay. So I'm going to solve this for L. And if I want to get L by itself, what do I have to do? Subtract H from both sides. So I'm going to have L is 2000 minus H. Okay, so then I make my substitution by going over to my other equation, right? So this is a crucial thing. You have to use the other equation when you make your substitution. And now wherever you see an L in your other equation, you're going to substitute. You're going to substitute that L with a 2000 minus H because they're equal. L and 2000 minus H are the same. So I can make a replacement, replace the L with a 2000 minus H. And now I have an equation that has only H's in it. And that we know how to solve. What would you do next? Simplify how?
Multiply 0.04 times 2000 and 0.04 times.
Yeah, so I'm going to distribute that 0.04. Let's see if I could do this in my head. 10% of 2000 is 200. 1% is 20. So 4 1% would be 80. Minus 0.04H plus 37. All right, now what? Yep, so 0.09 plus 0.04 is 0.13. And I'm going to combine my like terms of the 80 and the 37, and I get 117. Can't do that in my head. 117 divided by 0.113, 900. Okay, so H is 900. How do I figure out what L is? Yeah, I go back over to the equation where it has L equals 2000 minus H, and I substitute again, right? Now I know L is 2000 minus, substitute the H with a 900, and I get L is 1100. Okay, so I've got my two solutions. And my very last thing I should do is to answer the question, right, with a sentence. So somebody say, what do those two numbers mean?
Means that Gary invested $1,100 in the low interest account at 0.04% interest. He invested $900 in high interest at 9%. High interest. So all we have to do is figure out the interest secured over 4 accounts. We should come up with $37
Yeah. So this is the answer. This sentence is the answer. If you want to check it, take 4% of 1100 and 9% of 900, and one should be $37 bigger than the other, right? Thereabouts, yeah. All right, good. Checking is important. Oh, look at, I did it on the wrong page. Oh, well. Yeah. So here's a sort of a general process. Define a variable for each unknown quantity, right? Do that by looking at the question, right? So underline the question, use that to define your variables. Organize your information in a table. A table can be helpful in a lot of instances, but not every single instance. But this is sort of a general table that would work. You get two kinds of things, two kinds of investments, two kinds of candy, two kinds of acidic solutions. Yeah. And then you have an amount and a unit value like dollars per pound or interest rate, and then a total value. Step 3, write a system of two equations. You have to ask yourself what equals what. And then solve the system, and you can use one of the 3 methods that we've learned. We just reviewed one of them, substitution. And then check your answer and describe your results. All right, so I'm going to let you try some. These take some practice. Don't be afraid to call me over if you get stuck. That's it.